Hello everyone and welcome back to the next lesson. This lesson is going to cover repetition, repeating a process over and over and over again until you get the results you need. My examples here aren't going to be the best. They're going to be very, very simple, but the idea is to get you to understand how loops kind of just work. I do have a couple very simple examples, but we're going to keep it a little limited today because this stuff is going to be much more of an important factor later on when we kind of look at more complex ideas. We'll revisit them. So, what is looping? Looping is an extremely common way to make a computer do something over and over again. There are three and a half ways to make a program loop through a process. So, for example, there's a for loop, which is probably the most common, and are great when you need to crunch through a list of data. One of the reasons that we're keeping this really simple is because one of the most common lists are called arrays, which we haven't covered yet, but we will in the next lesson. So there's also the while loop. While loops are used when you need to loop through a process, but you don't necessarily have a clear foresight as to how many times you need to loop through it. For loops are great if you know how many times you need to loop. While loops are more tricky. They're simpler to write, but they will just keep going until a certain condition is met. But usually use a while loop if you don't know exactly when that loop is going to need to end. Do while loops are the exact same thing as a while loop, except they will always execute at least once. While loops may or may not execute more than once. So then the last one is a for each loop. For each loops are used with arrays and other lists as well, but they go cell by cell. So an array is like a list of cells, right? And it goes cell by cell. For each cell inside of a list, execute some sort of code to this. Because we haven't talked about arrays, and these are probably, well, in my opinion, not the most common, we're not going to touch the for each loops. Not yet, at least, because of the fact that they require your understanding of arrays. So we're going to look at the first three, for, while, and do while loops. So the reason I say that there are three and a half is because the while loops and do while loops are the exact same thing. So they're like kind of different. They're exact same thing except for that one difference where the do while loop will execute at least once. So here's a for loop. Let's kind of conceptualize a for loop before I show you how to type one out. In a for loop, you start by making a variable in the loop and initialize its value. So just like in the past in the first lesson where we did int I equals 5 or int I equals 0 or int I equals 1, we're going to do that too. We're going to start with a value. Then we're going to check that value against some sort of condition. Just like we did in if statements, how we checked the variable to see if it was equal to, less than, or greater than a value, we're going to do that too. If the check is true, so like let's say that our integer is 0 and we're checking to see if it's less than 10, right? That's a true statement. 0 is less than 10. What it means is we're going to enter the loop, execute some code, and then we're going to increment or decrement the integer or the variable, and then check it again against the next or the same condition. If false, and we're going to keep doing this actually, we're going to keep going around and around and around. If that check is ever false, we're going to end the loop and continue on to the next line of code. Be careful with infinite loops. When setting up a loop, Java, or any language for that matter, will not check ahead of time to see if your loop is infinite, because intentionally making the loop infinite is a common practice, but it can lock up a thread when unintentional. So, I'm sorry, I didn't mean to read that, but the following loop is kind of infinite. I say kind of infinite because it actually will end. It just might take a minute. It might just take a little while. But let's look at why it's potentially infinite, right? So in a for loop, we start with int I. This is actually what the syntax looks like for the for condition. We define a variable right here, just like we do any other variable, except instead of doing it before the for loop, we're going to do it inside the for loop. And that's actually going to be important later on today. So we start with an integer. We create an integer called I, and we set it equal to 0. And then we put a semicolon there. And then we're going to check to see if it's less than 10. This is our condition. And just like for the if statements, their conditions can be as complex as you need them to be. If I is less than 10, we're going to execute the code. We're actually going to go into the for loop, execute a bunch of code. When we're done, we're going to, in this case, we're going to reduce I by 1 and then check again. The problem is, as you can see here, that I is 0. I minus minus will make -1. So -1 is still going to be less than 10. In fact, because we're going down, we're going to go down infinitely. If we're always going to be less than 10, because then we're going to go -1, then -2, then -3, and then -4. We are never going to be more than 10. Now, if you were listening or if you had watched the very, very first lesson on counting and bits and bytes and binary, you'll know that eventually we actually will hit a maximum negative number. If we hit that maximum negative number and then decrease by one more, we will actually go positive. We'll hit the maximum positive number. It's called underflow. In that case, we will actually stop. But for conceptually, this is technically, no, not technically, but this is conceptually at least an infinite loop. Yes, this will technically end, but you see the problem here, right? The intention was to make this iterate 10 times, but this will iterate tens of thousands of times. The way to correct this would be to change this to a plus plus. All right, so let's make a for loop. So I have a new project here, or actually I don't have a new project here. Let's make a new project here. Let's do lesson 4 loops. Create a new class, lesson loop practice. And again, we're going to delete all that, and create our main method. Oops. There we go. And we're just going to create a simple for loop. We're not going to do this example. Actually, we will do this example, but we're going to not do it at 100. All right, so let's just make a loop. All I want to do is increase, I want to do the factorial. If you don't know what the factorial is, you input some sort of number. In this case, it starts at 100. You multiply this number by the one less than it, and then you get some value. Then you multiply this by one less than this, right? So you start at 100, multiply 100 times 99. Then you take whatever that is, multiply it by 98. Multiply that quotient, or I'm sorry, product by 97, and then by 96, all the way down to 1. So let's do this. Gonna give me some space here. I'm gonna start a for loop. I'm gonna create an integer, int I equals 0. Your variable can be whatever you want. I just like to use I typically. I less than 100. And then I plus plus. Now, I could do it this way, and this is actually what you're seeing here is the more common way to see a loop. You usually start at 0 and you go up to some number but not including the number. That's why I'm not putting an equal sign right there. This is the more common way of doing things. However, because our example has us go from the factorial has us start at a number and goes down, it kind of makes sense for us to kind of follow that math, doesn't it? So I'm actually going to flip this around. I'm going to say I equals 100. I greater than 0 or 1. Actually, yeah, let's do 1. They'll actually both yield the same result. And then we'll do I minus minus. So we're going to start at 100. We're going to count down to 1. Does everyone see how that works? Start it, create an integer, start at 100. Compare it. Is 100 greater than 1? If so, execute the body of code between these curly brackets. At the end of that, decrease I by 1 and then check again. And then decrease by 1, check again. Decrease by 1, check again. Keep doing this until this condition is false. All right, so I actually need one more variable. So I'm going to make an integer before the for loop called int total equals 1. And the reason I'm going to start with 1 is because if I make it 0, you're about to see how it'll make it 0 no matter what. Let's actually start at 10 because 100 is going to cause a problem that we're going to see in a second here. Now, I know that we're going to start at some sort of total. We need to multiply I times I minus 1. Now in math, what this will actually do is it'll multiply I first. So it'll do 10 times 10 minus 1, but that's not what I want. I want to do 10 times 9, right? So we can do this. This is one solution to this. But actually what I want to do is I want to take the total times I. This is going to be a little bit better actually. So the previous one actually probably wouldn't work, but that's okay. I'm showing you that there's actually multiple ways of doing this. So if I start with a total of 1 and I multiply it by 10, that starts with 10. Then I becomes 9. So total is still 10, but I is now 9. So 10 times 9, right? And then we store that and decrement I by 1 more. So the total times 9, then total times 8, total times 7, total times 6, and that's exactly what the factorial is. Just to see how this works, or just to see that it's working, I'm going to do system.out.print line total, just to see what the product is every time we loop. We're going to compile this, and we're going to run this. I'm going to expand this so we can see the whole thing. So here we go. Total starts as 1, right? Then we have a loop. The loop creates another integer called I, and we set that equal to 10. Is 10 greater than 1? Yes. Then we enter the loop and we do the math. Total, which is 1, times 10 is 10. So total equals now 10 at the end of this line. That's why we print out 10 first. Once we're done with this, we decrease I by 1, which is what this minus minus is. So now I is 9. Is 9 still greater than 1? Yes. So do total, which is 10, times 9, which is 90. And then 90 times 8 is 720. And then 720 times 7 is 5040. 5040 times 6, times 5, times 4, times 3, and then times 2. We could go all the way to 1, but you just get this number twice, and that's kind of redundant, so I don't want to do that. Okay. I'm going to switch this number to be 100. Oops. I'm going to clear this out, and I want you to watch what happens. Okay, we get a bunch of zeros, but if we actually look at the values, if we scroll all the way up, we have a problem. I starts at 100. 100 times 99 is, I'm sorry, so 100 times 99 is, I guess, 9900. Yeah, that's right. 99 times 100 is 9900. Then 9900 times 98, then times 97, 96. We get numbers so big, so fast that we actually create overflow. That's why we're getting a negative number here. Then this times whatever the next number is so big that we actually go back into the positive numbers. And then we keep going up and up. And so you're seeing this switch between positive and negative because the numbers are getting so big and going around and overflowing so many times that it's actually going back and forth between the positive and negatives. Right, so we got underflow. So whenever we get a negative, negative times a positive is actually going to go down. So we actually get underflow between here and here, and then overflow from here to here, and underflow, etc. Eventually, we get so big that the bits inside of the integer get pushed so far out that all the bits become zeros. That's why the integer actually becomes 0 by the end of it. This is something to be careful of when you're doing extremely large kind of numbers like this, right? You got to be careful for overflow and underflow sometimes. So I just wanted to show you that real quick. So this is the basic structure, by the way. Don't forget, you have to create a variable here. You have to actually do it here, semicolon, a comparison, semicolon, and then increment or decrement. You have to do some sort of incrementation or some sort of arithmetic right here. Incrementing and decrementing I++ or I minus minus are the most common. Then if this is ever true, you execute this code. Okay, I've said that like 3 times now. I don't want to say it again. Okay, while loops. While loops only have a condition, no initializing of variable, and not automatic incrementing of that variable. It simply checks a condition, and if it's true, it does the statements, and then checks the condition again. So basically, it's doing the same thing, except it's getting rid of this part and this part. All you have is the condition. So if you want to keep this, you can, and just write something underneath it, but I'm going to delete all of this, right? So we can make a while loop. We're going to add a while loop to our example program that simply asks the user if they can hear them. If yes, repeat. If no, shout damn. All right, so we're going to practice a couple things. First, as I said in one of the earlier lessons, we want to get data from the user. So this means we have to create something that can get input from the user. Now, you don't have to know what I'm doing here yet because we haven't covered this yet, but I do want you to just copy this. I don't want you to do import at the very, very top. Import capital S system dot in. Oh, actually, it's java dot util dot scanner. That's what it is. Sorry. And then inside the main method, we want to do scanner in or whatever user input equals new scanner. And then in between, we want to do system.in. All right. You don't need to know what this is yet, but you do need to copy it. Remember this import statement and this one line of code. Next, I want to do a string, right? I want to do a string. Let's call it response equals just a blank string for now. Now I want to ask the user. I need to ask them at least once, right? Can you hear me? System.out.print line. Can you hear me? Question mark, close, blah, blah, blah. Great. Response equals, oops, user input, this thing right here, dot next, open and close. This is called a function, by the way. We'll learn about methods very, very soon. But basically what happens is whenever you see user input dot next, or what you'll see most common is just in this variable. This is a variable. It'll be called in. It's just going to wait there and it's going to force the user to respond. You don't need to know about this. For now, just copy this. So we'll do a while loop. Response. Remember that response is a string. Strings are reference type variables. So I want you to just copy what I'm doing here. Response dot is equal. Yes. I didn't mean to go that far down, but that's fine. Is that right? Wait a minute. Let's actually look this up together. I must have forgotten it. Java string comparison. There we go. Look at that. I must have looked it up recently. Let's see. Equals. That's what it is. Okay, I forgot the S. System.out.println. And then it is a good. Can you still hear me? And then response equals in dot next. Okay, so let's kind of stop there and see. Close you. Go away. Let's see what's going on here. There's a lot that you may or may not understand what's happening, but that's perfectly fine. Trust me, you're not going to fall behind if you don't know a lot of this. We create a new scanner object, and basically you have to have this. This is the name of the variable, and this variable has functions inside of it that we haven't figured out yet. We haven't learned much about them yet. So I have an empty string variable. It's empty right here, and the variable's name is response. I first ask the user, can you hear me? And then the computer waits for them to type something, anything. It takes whatever it is and stores it in response as a string. So now response is holding something at this line of code. And that something could be yes, it could be no, it could be TFD, RN213, it doesn't matter. It's going to be stored as a string. Then the response, you can't do response equals equals because remember these are strings. And if you do equals equals, equals equals is comparing the references because remember that strings are reference type variables. So in order to do this, in order to compare the response to the word yes, you have to do response.equals. All right. I'm starting to believe that this may not be the best example, but I'm showing you a whole bunch of stuff right now. So if response is equal to yes, I'm going to say good. Can you still hear me? And then we're going to do it again. See this line? It's the exact same line of code. We're going to keep going until they type in something other than yes. If they type in something other than yes, the loop ends. And then I want to just output damn. That's it. So let's try this out. Can you hear me? I don't need this to be full screen anymore. Sorry, I'm just going to make this. There we go, much more manageable. Okay, can you hear me? Just do yes. Good. Can you still hear me? Yes, 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 yes. So this is what I'm saying is could potentially be an infinite loop. With the for loop, we're only going to execute this. The for loop that we did last time is only going to execute a specific number of times. This while loop is conditional, but it doesn't know the condition yet. Well, it knows the condition, but it doesn't know how many iterations. It doesn't know how many times it's going to repeat itself. It's just going to repeat itself until this condition is false. That's the only really thing I need you to understand here, really. I don't care if you don't understand what this in scanner stuff is and the response, but the point here is if I type in anything else, damn, we skip the while loop or we finish the while loop and we continue on. And remember that when we get to the end of the main method, this main line, this curly bracket right here, the program is done. If I were to set this to true, by the way, you can hard code this like this. Unreachable statement, yeah. I know, I know. Oh, I forgot. It actually is going to just keep going and going and going. There's no way for me to exit. I forgot that we had this response. But I want to move on. I hope you understand the while loop. By the way, in this, if you want to force it to quit, because if you notice this right here, it means that it's still running. This little button right here will actually force it to quit. All right, so we made a while loop. It was a very complex while loop. So if you didn't understand it, that's kind of fine. I just need you to understand how the for loop or the while loop is structured. The do while loop is just like the while loop, except the condition is at the end of the statement instead of the first check. It doesn't happen until after the execution of code. So let's try that instead. It's been a while since I've made this, so hopefully I can do this correctly. I'm going to put the while statement here, and I'm going to say do. Hey, I did it. So what's going on here? It's the exact same thing. The loop hasn't done. The only difference is I'm going to execute this once. Now the nice thing is, remember up here how I had to ask the customer, I had to ask the user at least once because before I hit the while loop, I have to have a response, right? But now I don't need that response because I'm definitely going to ask them once, can you hear me? So I can actually delete this. So let's see how this works. So I create my two variables. You can kind of skip this, but we start off with like an empty string variable. When we get to the do statement, no matter what, we enter the do statement and we do the first line of code. We print something. Can you hear me? Actually, I should probably say can you hear me, not can you still hear me? Can you hear me? And then it waits for the user's response. Once we get the user's response, we need to do that condition. Response dot equals yes. And if it's yes, then we go back to the do while and we keep going. This is how we force it to execute once and then do the check. Before, we did the check first, and because we did the check first, we had to have some sort of initial value before we entered. Can you hear me? Yes, 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 no. Oh, I forgot. I don't have the damn statement anymore, so it just ends. That's fine, though. All right, do while. So there's the do while code. Here's an example. We have an integer x equals 21 and sum equals 0. This line of code will be printed even if the condition is false. Sum plus equals x. So 0 equals 0 plus 21. So x, so the sum is going to be 21, and then on this line of code, x is going to be 20. System.out.println summation equals sum, which is going to be 21. It's going to do this while x is greater than 10. So this will execute once, but if you notice, so this will actually, execute 11 times or 10 times? 10 or 11 times? Yeah. Before it stops. But even if you change this x to equal like 0, it'll still work once. Okay, also known as the enhanced loop for each loops. These loops will iterate through each value of a list. We'll revisit these loops later. We'll revisit them later when we go over arrays, which is the next lesson. We've already seen the keyword break, but I want to bring it up again. You can put if statements inside of loops, right? Or you can just have a break word. So if I put the word break here, it'll execute once, but as soon as you do the break, it says, I don't care what your condition is, you're done with the loop, period. You can use conditional statements like making a loop, like a while loop, and then inside of that while loop, you can put a condition like if this, like the if statements that we did last time, you can put them inside of these while loops, and if it hits a certain condition, you can use break that forces the loop to end. So let me just kind of do a quick while loop here. While true. So remember, this should be theoretically infinite. But I'm going to do if response dot equals yes, no. Break, else, do nothing, I guess. Oops, Esli is not a word. Right? So this, we're actually missing response. Sorry, I forgot. Response equals in.next. There we go. If response equals no, break. So this is one way to force it to stop. Let's see and step through how this code works. Oh, that's right. So if you're wondering why it's blank, remember we create our variables, whatever, it's blank, whatever. We go into the while loop. The first thing it does is actually wait. It doesn't ask, can you still hear me? So this code is actually going to be quite different. I can type in anything I want, and it's going to keep asking me because this is not true. So if it's not true, it's going to go to the else statement. The else statement says do nothing. Well, the only thing after the else statement is the end of the loop. So it goes back and it does it again. If I type in no, that's when I hit the break. The break tells the while loop to completely leave. And then it continues on with the code. And then it hits the end of the main method. And that's the end of our program. I think this next part should help us out after the nested loops. It is possible to put a loop inside of a loop. Nesting loops can be a great way to go through a data structure that has columns and rows. So in the future, when we talk about arrays or multi-dimensional lists or data sets. Think of like a Microsoft Excel spreadsheet, right? Think of a spreadsheet that has rows and columns. You may want to start on row 1 and go column by column, or you can start on column 1 and then go down a list, and then when you hit the bottom of the list, go to the next column and then go down and then go to the next column and go down, right? That's a way that you would want to use nested loops. We will, again, talk about this in the next lesson, but I want to bring it up that you can nest loops. All right, scope. The following is a deviation from the main topic. So we've been using scope this whole time in order to, but we haven't really talked about it. Okay. How do I explain? So this is a tricky one to explain. Scope is the level of access something the program has to a specific variable. All right. The variables created between the curly brackets only exist inside that curly bracket. You cannot access the variable outside of it. So for example, let's say I have the main method. How do I undo that? So let's say I have the main method. And then, so just to kind of shorthand this, I'm going to do main method here. So this is our main method that we should be pretty familiar with. Okay, I'm shorthanding this. I'm not going to write the whole thing out. I create a variable int a, and let's set that equal to 0, right? And then if I create a for loop, let's say I create an if statement. If some sort of condition, right, some sort of condition. I can do like a plus equals 1. So inside this curly bracket, I have access to something above it. If I did this instead, if I put int a here, and then over here I did a plus equals 0, I'm going to get an error, right? So the scope is the level of access something has to the variable. Let me kind of draw it this way. The reason I can't do this is because a is defined in as a variable underneath the scope. So for example, oops, oh no. We're not ready for that exercise yet. In my code, or in this, oops, in this program, you've noticed that there's these colors. The colors are the scope. So notice that here's a level of scope right here from the beginning and end of the while loop. We have access to something of higher scope, which means that this and this curly bracket, because it's higher than it, right? Every time we kind of tab over, the tabs aren't actually important, but every time we tab over or we create like a curly bracket, then that's the beginning and end of our scope, right? So this if statement has a scope from here to here or here to here. And it's lower than the while loop. And the while loop is lower than the main method. And the main method is lower than the loop practice. Things of higher scope have access, can be accessed by lower scopes, but the things of higher scope cannot be accessed. Things of higher scope cannot access lower scopes. So watch this. I'm going to delete this whole thing actually, just to kind of show you what is going on here. Let's say I make an if statement. If true, we're just going to force it to be true. Int a equals 0. This is on a lower scope, which means if I go to a higher scope and try to access it, I will be denied. A plus equals 1. Anything I do cannot find symbol A. Okay, but if I switch this, even if I do this, well, we know why this isn't going to work, right? Because right? Now it's saying cannot find symbol A. That's because this is made after that statement. So if I put this at the beginning, I'm sorry, this is getting really confusing, but now everything seems to be fine. Why? Because remember that if I'm in a lower scope, I can use the variables from a higher scope. If I'm in a higher scope, I can't use variables of a lower scope. Later on, when we get to methods, we will actually make something outside the main method. So will I have access to that thing no matter what it is? The answer is no. Well, we'll show you how you can access it, but not directly. Not like this. This is directly accessing that variable. Because in order to do so, you have to go up a scope and then down a scope. As soon as you try to go up a scope, you lose access when you try to go down back to a scope. Okay, all you need to know right now, if that was way confusing, which I understand if that's perfectly fine if it is, all you need to know is that scope is the level of access in which you can use, scope is the level in which you have access to a variable or something. And you can go, when in a lower scope, you can have access to higher scoped variables. And if you're in a higher scope, you do not have access to variables created in lower scopes. So let's try something else. If I do int I, if I do for int I equals 0, I less than 10, I plus plus. Oops, I forgot to close this off. Right, I can do something with I in here, right? I can do I don't know why I just print everything. We can't really do much yet, but I'm sorry, but we will soon. We're just going to print I. What happens if I try to print I out here? Right? It doesn't know what I is because I was created in the for loop. This counts as being in the for loop. The for loop is of a lower scope. Because we created it in a lower scope, I cannot access it. Actually, I think you can do this. Oops, not I. A. See, oh, A and A. So why can I do this? Because the A variable was created in a higher scope. So this print line has access to it. When I do the print line, remember I have access to it if it's above me. But things above me don't have access to things below it. Which is why both of these are fine to print it out. By the way, this is rare to do. Don't really do this unless you have to. We will get used to scope very, very quickly. By the way, everything has scope in terms of other languages also. So in Java, the scope is visibly clear because of the curly brackets, right? It tells you where the new scope starts and the new scope ends. In languages like Python or GDScript, the scopes are not shown through curly brackets. It's shown through tablatures, which means like in Java, do you see how this is tabbed over from this? It shows that it's in a higher scope. Yes, Java is a little overly redundant because it's doing both. However, I can actually get rid of this tablature and Java will still run completely fine. It just doesn't look very good, so we don't do it. This is one of the reasons a lot of people may not like Java because it's doing both. You have curly brackets and tablatures as convention. And it's just like, why do I have to use both? Technically, you don't need the spacing at all. The curly brackets are what matters in Java, but in other languages, having it tabbed over is actually the important part. Okay, let's quickly run through this exercise. There's going to have to be a couple new things, so I'm going to just go ahead and delete all of this. All right, make a program that generates a random number between 1 and 1,000,000. So in Java, there's a way that we can create a number between 1 and 1,000,000. And that's going to have to use the math.random class. So if I just Google math.random, Java math.random. Oops, I didn't mean the E there. Okay, you can see a little quick tutorial from Geeks for Geeks on how this works. Math.random double. So what this does is this line of code right here will generate a number between 0.0 to 1.0, but does not include 1.0. So what that means is it creates a number between 0.0 and 0.999999999 repeating. That's why it's called exclusive. It's 0 to 1, not including 1. And then it's going to store it into a double, right? So that's going to be the first thing we want to do. Double rand equals math.random. I don't think we need to import anything, do we? No, we don't have to. Now, in this case, they imported it. I don't think you have to. So now we have a integer, or not an integer, we have a double between 0 and 1, but not including 1. So what I'm going to do is I'm going to create an integer called number, I guess. I don't know, number to guess. And that I'm going to do is I'm going to do this weird thing where I put int in parentheses just for a second. Then I'm going to do random times 1,000,000, 100. I lost track. Shit, how many zeros was that? 3, 6. There, that should be 100. Oh, that's 10. 1, 2, 3, 1, 2, 3, 1,000,000. Okay, cool. So now it does random, which is, let's say it's like 0.1. So we have times 1,000,000, that's going to be, what is that, 100,000, right? This line forces it to become an integer, and then we store it into an integer. Because without this line of code, or not this line, but this integer in parentheses, Java's going to complain. It's going to say lossy precision, right? When you take a double and store it into an integer, you're going down in precision because you're chopping off a lot that could be important after the decimal. But I know I want to. So this is a way to tell Java, I know that what I'm about to do is loss of precision, but I don't care. This is what I want. So I take my random number, create it between 0 and 1,000,000, and then I multiply it by 1,000,000, and I store it. So this is going to generate a number between 1 and 1,000,000. Let's see, what was the next thing we have to do? The user will guess a number, and the program will tell them if they are too high or too low, or if they won. So I'm going to do a do while. Do while, user guess equals 0. Okay, while user guess not equals 0, because I want to check to make sure that the user's guess, not 0, number to guess. If the user's guess does not equal the number, they need to guess again. I also want to give them maximum 20 tries. So I'm going to say int tries equals 20. Let's make it a final int tries equals 20. That looks weird, but I don't care. Actually, let's make this max tries. And then int attempts equals 0. Okay, so if you're wondering what I'm doing here, I don't need to make this a final. I just want to so we can remember how to make constants. So every time the user guesses, we're going to take attempts and we're going to increase it by 1. Then we're going to check to see if they've made more than 20 guesses, or actually equal to. And if the user's guess does not equal the actual number and attempts not equals 20, we're going to guess again. So, okay, so we know that those are the two conditions. If the user didn't guess the number and they haven't guessed 20 times yet, we're going to do this loop. Now, so let's actually force them to guess. Okay, well, let's ask them to guess. System.out.println guess a number between 0 and 1 million. And then user guess equals, I need a scanner object, because remember the user has to put an input. Scanner in equals new scanner system.in. Okay, user guess is in, because of this thing, in dot next int. Just do this. It'll force the user, the user's next integer will go into there. System.in. Yeah, that's what it was. Sorry, didn't mean to put the parentheses there. Okay, so it says please guess a number between 0 and 1 million. If the user guess is less than or equal to, or is less than, what is it? Number to guess. We're going to output too low. Else if user guess is greater than number to guess, system.out.println too high. Okay, a couple things. Let's stop there for a second. First of all, I don't want to use an else statement. Why? Because if the user guesses correctly, then we need to stop and say you won. Right? Actually, you know what? Let's do that. Let's do else if. Actually, we can just do an else. Else. Actually, hold on. Let me think about this. We can do this a couple ways. Here, let's do it this way. Let's forget the else statement, and I'll show you why in a second. All I want this to do is check if it's too high or too low. If it's too high, then we want, or if it's too low, print too low. If it's too high, print too high. What we're going to do is we're going to check to make sure. Actually, you know what we do? We'll do. Sorry. Else if, I should really prepare this better, but I'm so out of time during my day. User guess equals number to guess. I always do that SL. Then system.out.println you won. And then I want to do a break, right? Because if you win, you don't have to guess anymore. That's it. So I guess we could change this from a while loop, but let's stick to the while loop the do while loop that we got. Let's see how this works so far and see how we need to change this. And let's see. I know this is not going to work right away, but let's see how far we got. See if we can make what changes we need to make. Guess a number between 0 and 1 million. Let's do 500,000. Too high. All right, 250,000. Too low. Let's say 325,000. Too low. 410,000. Too low. 490,000. Too high. Okay, so we can keep going and going and going. I don't know what the number is, but I just want to force this to quit. So at least we know that this loop is going to keep going until we guess it right. Well, we don't know that because we haven't actually hit the number yet, but let's see what would happen. What happens when we lose, though? If the user does not guess the number and the attempts equals 20, right? Because eventually, oh, that's actually something we forgot to do. If you notice that we're not incrementing attempts, at the end of this whole thing, we should always increment attempts by 1. Attempts plus plus. There we go. That's something we forgot to do. But is that enough? Let's see. Guess a number between 0 and 1 million. User guess equals next int. If the user's guess is too low, then say too low. If they guess too high, say too high. If they guess right, say you won. I guess we can do one more else if statement. User guess not equals 20 and actually not equals 20. What am I talking about? If attempts equals 20 and user guess not equals number to guess. You lose. Oops. Okay, this is not my favorite solution to this, but it kind of works, right? We are always going to loop through this. We're going to loop through this once. We're going to force them to guess. Then, based on what they input, we're going to make 4 guesses. We could probably improve this, but I just want to move on. We're going to check and see if they're too low, tell them they're too low. The else if they are too high, then we'll tell them too high. And then if they guess right, tell them they won. And if they run out of guesses, tell them they lose. If they didn't guess the number and they need to know that they lose. And we could technically put a break in here, but we don't have to. Because this check right here is actually the exact same thing as this one, sort of. Now this check just makes sure that it's not equal to 20 and they didn't guess it right. Give them another shot. But as soon as it equals 20, this condition is going to be met. Right? This is going to be met. Actually, will it be met? If the attempts not equals 20, but if this equals 20, but they guess wrong, that'll be false, and then we should exit the loop. Yeah, so okay. So once we hit 20 guesses, this while loop will stop, and then we'll leave. The problem here, though, is we can leave because we either won or we lost. So this alone won't be enough for our check. That's why this might seem a little redundant, but that's why I'm doing it again right here. These are very similar checks. And I'm using the break because as soon as they run out of checks, they say you lose. Actually, I want to do system.out.println. We'll do number to guess, right? Just to print out what it was. Okay, so 20 guesses is what we're doing here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Too low. Oh, okay, so why didn't we go to the you lose? Because it's a good thing we tested this. Because the first condition it checked was if we were too low, which we were. We were too low, so it did this and never got to this last one. So what I actually want to do is completely separate that if statement. If you if the number doesn't match and attempts equals 20, tell them they lose and then break out of there. Compile. Okay. I'm just going to guess 1 20 times. Guess a number between 1 and a million. 1 too low. Oh, because of the breaks. No, wait. I don't see a you lose. Where's the you lose? I should be there. Let's try this again. We messed up something. I messed up something. Guess a number between 0 and 1 million. Okay, so 3, too low, skips this. If attempts equals 20, and the user... Oh, you know why? Because attempts is all the way down here. Let's see what happens if we actually put this at the top. Let's try it again. So what happened there was, I didn't even catch that. What happens there is if the attempts is at the bottom, right? Attempts becomes 20 down here. So attempts is 19. It's going to skip this and then it becomes 20 down here. And then this checks for 20. So this will actually never happen. So let's put attempts up there. Come on. All right. I'm just gonna do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4. Too low, you lose. The number was 567,924. Okay, so our 20 questions game is now technically working. Is this the best solution? Maybe, maybe not. There are a couple ways we can clean this up a little bit. Remember that if you have one line underneath an if statement, you don't need both the curly brackets. So let's actually get rid of that. And get rid of this. This has 2 lines, so I do need the curly brackets. This has 3 lines, so I do need the curly brackets. But this will technically work. If you want to take the time to actually make this better, or if you want to use a for loop or a while loop, because a for loop will do just fine too. Remember, for loops, you can just do int I equals 0 if I is less than 20. You can do that, or I equals 1 and then less than or equal to 20. You can do it that way. Try another way, and then see if you can get this 20 questions game to work using a different type of loop. All right, but so there's our solution. Get some practice with some loops, understand scope, understand if statements and loops and variables. Remember this line of code if you want to generate a random number. And remember this line, this is an old one, but remember this one if you want to force input from a user. You can look up the scanner. You can go to Java and then look up the scanner class if you want to look up other things that you can do with this. But for now, let's just leave it at what we're doing here. And I will see you guys in the next lesson, which is arrays. Thanks.